Are you talking to yourselves a little bit to go, okay, I have blank, blank, blank. I don't have blank. All right, eyes up, eyes up. Let's look at number 2 together. Okay, so number 1, give me a thumbs up if you were able to solve number 1 pretty successfully after a minute of like thinking. All right, cool. So I think that most of you guys did see your stoichiometry came first because you did not have a gas at first, so you had to get the moles of gas using your mole ratio. All right, Margaret, tell me your start for number 2.
I started with the idea of gas law.
Solving for what?
Moles of oxygen.
Good. So she had liters of oxygen. And so if you label O2, it'll force you to say, I have oxygen, but the question wasn't even about oxygen, right? So you got your liters of oxygen, you plugged into your ideal gas law by using appropriate units. What did you get for your moles of oxygen? 1.20 moles? Okay, so then what did you do with this information?
I used the mole ratio from the mountain.
Mine's way on top of the board, so you're going to remind me of that.
18.
Okay, and so this is a huge ratio, right? Because we have a combustion reaction with octane, which is what you put in your gas tank. Who actually gets gas? Who has pumped gas in their lives? Oh, so many of you have so much to learn. All right, do you guys know what button to push for your car? Which octane level do you get? Let's start with low, medium, or high. The low, okay, so who has like the super octane car? So you like, we don't have a car. Okay, well, how about a home in general? You can also have an electric car. You may not need gasoline. That would be awesome. We'll be friends if you have an electric car, because that's my next car. It's coming soon. Okay, but regardless, you will see that you have octane levels, ratings on your gasoline, 93, 97, 98. I'm never get the super octane one, so I don't know that one. All right, so once you get here, though, do you stop here or do you keep going, Margaret?
Keep going.
And what are we going to?
Grams of water.
So then 1 mole of water goes on bottom, and our molar mass is 18-ish, right? And so what's your grammage at the end? 15.5 grams of water. So this is where sig figs will come back into play, right? So this is our oxygen will cancel, moles of water will cancel. The sig fig limiting here was which variable they gave us to begin with? 1.3, right? So this is our 2 sig figs at the end. At the beginning. We see everything else has more than 2 sig figs. So this needs to be rounded to what? 16. Yeah. I usually look at the variables given to me because those are the measurements given to me at the very beginning. At the middle areas, you start to see like a ratio like this. So you see 2 and 2 there. Those are just ratios. Those aren't measurements. Measurements are what limit our sig figs. So usually I go back to the beginning for the measurements given, which are the givens given. Good point, Lindsay. Okay, so I'm going to halt on the rest of this for a moment. We'll pick up some more stoichiometry, but I just want to give you another taste to kind of get a fresh look at that because you haven't seen it in a while. Pull out your phones for Kahoot. Okay, if you don't have a phone that's going to connect very well, you have to just cross your fingers that Wi-Fi connects. If you want to grab a laptop, you can. But this is going to be somewhat of a grade because I want to make sure that you are taking it seriously for me. Okay, so I'll pull up the Kahoot pin. You need a calculator, get a calculator. If you have a periodic table in front of you, that might be useful. You can talk to your groups though, okay? Talk to your groups. That's where you're sitting with those people. They are wonderful people. They want you to do well. Alright, so the music's the best part. Here we go. I'm gonna I'm gonna leave the lights on like this. Code 499603. 499603. So don't put like bootylicious or anything. I need to know who you are. Caleb. I don't know you're bootylicious. Alright. So let's go. Give me some decent names here. And don't judge me for all my tabs. These are all your signs and boxes I'm still looking at. Alright, got 15. There's a couple more names that are still in there. So this is going to be a review of states of matter, gas laws, some gas relationships. It won't be very hard though, okay? So it's going to be pretty fast. I will always have the power to skip you, so you got to get on that. If you can't see, just make sure you get to the person you can see. Alright, I'm starting in just a couple seconds. I'll write this up here if you get kicked out. Okay, 27 sounds about right. And here we go, starting. Are you ready? You have to be. What? I'm gonna let you read that for a second. Where's my music at? There it is. Water droplets that appear on a steam window produced by. Oh, time was up, folks. It was fast, dude.
Last time I failed this. I wanted to.
Prani, get it together. Okay, so yes, condensing, right? Thinking about our state changes. We're going from wet to wet in this case. Wet to wet. Gas to liquid, right? So condensation. Next. Let me click from the board for a minute. See if this was going to cooperate. All right. Law that's represented by the picture below. So look at the picture. Fast. 7, 6. All right. Okay. Most of us did okay. What were the two variables, Darcy? What were the two variables? P and V, and that law is Boyle's law. P1 V1 equals P2 V2. Next, it doesn't want to click there. We're gonna keep trying. All right, Miles, nice. I don't know. Let's go. Which of these can be? No, so fast. I don't know how fast you guys are going. Which of these can be compressed? It's pretty fast. It's like a 10-second question. You can talk to your groups. Okay, great. Compress easily, gases. I don't know who these people are over here. Oh, pause. All right, hold on. You guys got a solid in your hand, right? You got a solid in your hand? I want you to compress that. Ain't gonna happen. It's not gonna happen. There's no way. The particles are already too close. You're not gonna be able to compress that. Liquids are not really all that compressible. Definitely gases. All right, good job, guys. What would happen to the pressure of a gas in a steel tank if it was heated? Think about pressure. Heat the gas. Ooh, nice. Lindsay, tell me why. But why? 4K! Okay, hold on. Carson, pick it up. Oh, I'm sorry. Cameron, pick it up. I don't know what Carson.
I was going to say that the particles move faster, so it creates the collision.
Thank you. That's what I was looking for. Collisions of the container wall is what pressure is, right? Collisions of the container wall. Nice, guys. Which of these takes the shape of the container it is in? Okay. Yes. We've got a couple people said liquids only. All right. So we got gases. Liquids can take the shape of their container too. They're fluid-like. Definitely gases as well. Keep it up. Temperature and pressure are blank related. Logarithmic. And here he goes. All right, I'm not going to go over that. You guys are good with that. Keep it up. Gas will always occupy the total volume of container. This is a true or false. Do not say I don't care. You have to care. Yay means true, nay means false. You obviously know how to make this, right? Yay or nay? Okay. Does anybody want to volunteer and say when it would not fill the container? That sometimes people. Anybody have a debate on that?
The container explodes.
Huh?
I guess I'll use my total.
Oh. Okay, I see your point, but I'm not giving the point back. All right. Oh, I was gonna let maybe someone justify, but there was no justification. What would happen to the volume of gas in the balloon if it was heated? Okay, most of us did okay there. All right, pause. Robbie, tell me why anybody would have put the green one just by chance.
Probably because they thought volume was mass.
Okay, so maybe I was gonna say maybe they thought something was remaining constant. Because does anybody have a debate for this? Yeah.
It may have confused Charles' law and Gay-Lussac's law, where in Charles' law
Volume.
pressure remains constant,
Yes, pressure remains constant.
and in Gay-Lussac's law, volume remains constant.
Right. So we definitely know that a balloon is stretchy, right? It's going to have an ability to move, and so if the the temperature increases. It's going to have to expand because the pressure needs to remain constant. If not, the pressure would totally increase and the balloon would pop. Right. So we definitely know there has to be an increase there. Nice, guys. Okay, keep it up. We're going to go a little faster here. What's STP? This is a nice soft picture here. Okay, nice. We're good. I'm not even going over it. I don't want to know who that one person was. In which state of water do particles move about most freely? I don't even know what vacuumed water is. I have to look into that. Not a thing. It's really clean water, guys. Okay. What is there between particles in a gas? Okay, guys, what is air made of? You can't have gas between a gas. That's a gas, right? What's between the gas? Nothing. Emptiness. Nice, Chloe. Gay-Lussac's law describes the relationship between. Oh shoot. You got your foldable right in front of you. You need to check. That cabinet right there. Okay. You just guys weren't fast enough looking at your foldable. All right. Keep it up. If the pressure of the gas goes up by 5, think about this one. The new volume will be. Ooh, okay, pause. All right, I don't know who got it right, so I'm going to ask for a volunteer on this one. Who can tell us the relationship here? Go for it, Maggie.
When pressure goes up, volume goes down.
Right, so my pressure, here's my box, right? Got your box? You guys didn't forget it, right? Box. Whip it out, people. All right, so increase your pressure by 5. 1, 2, 3, 4. What happened to your volume? It decreased significantly, approximately by 1 over, it's now down to the 5th of the volume, so right, 1 over 5. So indirectly related, good. Based on Boyle's law, if the volume increases from 20 to 60, at 60 atmospheres, the new pressure is. Okay, so you guys ready? You ready for a quick talk here? Right. Yes, I'm getting ready to. So then I left the math easy peasy for you. What law is this? It's Boyle's law. It says in the question, right? The relationship between Boyle's law is P1B1 equals P2B2, right? I gave you everything but what? I gave you everything but P2. However, the numbers are flipped, right? So the volume went from 20 to 60, and the pressure was at 60 when it was really, really small, but it relaxed to 20, which the numbers were exactly the same. You just had to think about it for a second. But you're right, 10 seconds was fast, but 10 of you guys are awesome there. Keep it up. What would happen to the pressure in a gas inside of a syringe? That's the little thing that you have the plunger with and you move it in and out. Right there. Oh, pressure. All right. Most of us did great there. Okay, you guys use these with the marshmallows, remember? Happy face marshmallows. Okay. The ideal gas constant. How would you have to memorize it? Watch closely. It's my favorite song.
Oh, yes.
I gave you like 20 seconds worth. Oh, all right. I need an explanation. Explanation on this. Why did we have 8 people over here in red? They just Butterfingers misread. They got, yeah. Simmer down now, folks. Simmer down. Okay. What are the conditions at STP? Again, you need to know STP. Okay, shame on you 2 people, shame. All right, I think I got one more. No, one more, two more. PVOT is known as combined gas law. Yay or nay? Maybe.
Oh, wait, don't Wait. Oh, that's ideal gas.
I'm not gonna explain that one. I just don't know who this is. Duh means like obviously, but it wasn't. Most of you did okay. Okay. When using the ideal gas law, volume must be in, this is a unit. Let's go, last one. Awesome. Good to go. Liters it is. One more. Convert Kelvin into Celsius. Yes, I got it.
Oh. That's actually a trick question.
It was not a trick question.
Oh.
It was a reading question. And I said it really loud, but we do know that we're going the other way, right? So you got to subtract. All right, here we are at the end. Dun, dun, dun. And then I'm just going to download this real fast. I do need this group over here. Go grab your laptops. This group, go grab your laptops while I download. Nice. Hey, beast mode. You got to be in beast mode when you come to chemistry. Final results.
How you feel?
Download the results. Okay, next group, go grab your laptops. I will grade by accuracy. I will check that out. Last group, go grab your laptops, yeah? You're going to get on Fountain Box. You can get on your laptop if you want to. You got a couple things you're going to work on, okay? All right, crew, open up to my website. I'm going to ask you to do a couple things right now together with me. All right, so as you're getting your laptop, listen up, okay? I have 3 things you're working on, and I want a little bit of each of them done. It's your choice how much time you spend on which ones, because if you don't finish, you know that you're going to have to do a little bit at night. So homework tonight is to complete at least half of the unit review. Half the unit review. So what I'd like for you to do is make some choices, and I do want a little bit of each one of them done. On my website, you'll see, at this link here, you'll see the kinetic molecular theory, KMT, kinetic molecular theory. It's got a couple review questions, got some simulations that go along with them. I'm not asking you to do the whole thing, but I think you guys are smart enough to figure out where your deficiencies are. You need a little bit of review on that. It might behoove you to look at that because there'll be a multiple choice question based on the kinetic molecular theory, some of the theory-based details, not the math-based details. So that's at this link here. I do have a number of you who have your Science in a Box stuff approved, so you're good to go. You need to start working on that in your groups because you're like, I have time together and I don't have teal, which I haven't heard anything else about teal yet because I'll let you know as soon as I do. You can get in your Science in a Box group, and or you can start a unit review. Where would you find the unit review? This link is not on my website, right? I'm going to leave this up here. Specifically, where on my website? Under the docs, which docs? Unit 5, and where under Unit 5? The student packet, the one that you've been working from with your from set 14. Okay, so I do have a couple of you who don't have your Science in a Box approved yet, so I would not start there. Give me a couple minutes and I'll look over them right now. But other than that, you have about 35 minutes or so to get your business done. Got it? Does anyone have any questions on what they're doing? Say, yay, I'm good.
Yeah.
I heard 2 people. Yay, I'm good. Yay. You guys are awesome. Thank you. Get to work. Yeah. Thank you. I know. Oh, yeah, this is the last one. Yeah, we should. Good point. All right, need your attention back in 5, 4, 3, 2, 1. I'll do that again. I need your attention back in 5, 4, 3, 2, 1. I just had a couple questions about what are we doing tomorrow and so forth. So tomorrow's Wednesday, yes? C. Okay. You're going to finish your unit review for about 20 minutes. If you need to actually, if you're ready to try to do a quick demo of your Science in a Box procedure, because you're like, let me make sure this works. You can do a trial run if you're ready. Let's see here. You'll have you'll have a 5-question quiz on gas laws, and I'm going to let you hold on to your fold books. I think it's a great study tool. Also, look over this a little bit so that you understand there's a bit of conceptual stuff there as well. 1 stoichiometry question. I'm telling you what's on there. Ready? 1 stoichiometry question at least. And then we're going to start looking over thermochemistry a little bit. Okay? So if you do want to trial run your procedure, I'll let you, but I got to make sure you're ready. Yeah. I'm gonna look at this right now. Oh, it's bad. I know, that's why I had to get some more.
It worked through the